Let's explore one of mathematics' most intriguing paradoxes: 0 raised to the power of 0. The first fundamental rule of exponents states that any number a raised to the power of 0 equals 1. This rule holds for almost any base value we choose. For example, 2 to the power of 0 equals 1. This makes sense when we think of powers as repeated multiplication. 2 to the power of 0 means we aren't multiplying 2 by itself at all, giving us the multiplicative identity, which is 1. Similarly, 5 to the power of 0 equals 1. In fact, we could use any non-zero number as our base, and the result would still be 1. Even a larger number like 100 to the power of 0 equals 1. The pattern is consistent. Any value raised to the power of 0 equals 1, regardless of how large or small that value might be. The second important rule tells us that 0 raised to any positive power equals 0. This makes intuitive sense. If you multiply 0 by itself any number of times, the result is always 0. For instance, 0 to the power of 1 simply equals 0. This is just 0 itself without any exponentiation. 0 to the power of 2 equals 0 times 0, which is still 0. The absorbing property of multiplication by 0 means that any product involving 0 will always be 0. And 0 to the power of 5 equals 0 as well. No matter how many times we multiply 0 by itself, we cannot escape the result of 0. Now, let's examine these two rules side by side. On the left, we have the rule that a to the power of 0 equals 1, which works for virtually any value of a. On the right, we have 0 to the power of b equals 0, which applies when b is any positive number. But now we encounter a genuine mathematical paradox. What happens when we try to evaluate 0 to the power of 0? We have two different rules that could apply, potentially giving us two different answers. If we follow our first rule, treating 0 as any other base a, then 0 to the power of 0 should equal 1. This follows the pattern we observed with all other bases. But if we apply our second rule, considering that our exponent is 0 and our base is 0, we might conclude that 0 to the power of 0 should equal 0, continuing the pattern for 0 raised to different powers. We've reached a contradiction. Should 0 to the power of 0 equal 0 or 1? Both answers seem plausible based on the rules we've established. This is what makes it a true mathematical paradox. To resolve this apparent contradiction, mathematicians have needed to develop more sophisticated approaches using limits, formal algebraic